Today we are going to see the we start unit 4 curve fitting. Okay, so first part of fourth unit is curve fitting and second part is correlation and regressions. So total fourth unit consisting of two parts. First is curve fitting, another one is correlation and regressions. The main heading of unit 4 is applied statistics, where we apply these things what we are learning. So first one here it is. So curve fitting, we learn that one fitting of a particular curve, so that is nothing but straight line, second degree parabola, exponential curve, power curve. Okay. So these are the four different types of curves you people will learn. Simply we'll say that linear curve and non-linear curve. So linear curve and non-linear curve. In linear curve is nothing but it comes only straight line, and non-linear curve we will get it as parabola or second degree polynomial, and next exponential curve and power curve. Okay, in exponential curve also we get two different curves. Okay, so those are the different curves we'll learn in curve fitting. And next one we'll learn correlation, what is meant by correlation, what is meant by regression, and how to find the correlation coefficient. And next one is rank correlation. All those things we are going to learn this particular unit. So here we are saying curve fitting. So what is meant by fitting of a curve? So simply one word we can say that finding the parameters appear in the particular curve. So that one simply we call as fitting of that particular curve. Suppose if we are taking as a straight line. So straight line is if we are taking the curve, here it is we say doing as like y is equal to mx plus c. So this one we are saying. So y is equal to mx plus c, in that finding m as well as c. These two we called as a constants, and finding these two constants is nothing but simply we can say that fitting of that particular curve will say here. Okay, so this is completely based on calculation part. So first we need to write the normal equations, and after writing the normal equations we have to solve those normal equations, and by using the given data we have to find what we require in normal equations. After that simply we substitute those values of x and y is nothing but simply will say that we get a required curve of best fit. Here it is simply first we are saying the definition. So and we are going to discuss this all curves by using the method of least squares. Okay. So what is meant by curve fitting? Here we are saying the exact mathematical relationship between two variables is given by a simple algebraic expression is called curve fitting. So it means that what we are saying, a relation between two variables. Okay, so here these variables are nothing but x is one variable and y is another variable. The relation, mathematical relation between two variables is given by simple algebraic expression. So this expression we call as a algebraic expression. If we are giving like a relationship between two variables, then we call that is a curve fitting. In other words, what we are saying, finding the parameters m and c is also we can say that curve fitting. So this is we called as a linear curve. Okay, so linear curve is nothing but straight line y is equal to mx plus c, and non-linear curve is nothing but we will get it as parabola or second degree polynomial, and next exponential curve and power curve. So those are also having specific expressions. We'll say that y is equal ax square plus bx plus c. So ax square plus bx plus c. So this is we'll say that in form of the parabola. In the same way, exponential means we'll say here y is equal to a e power bx. This is one thing, and another one is y is equal to a b power x. So y is equal a b power x. This is we'll say that in exponential curve. And another one power curve we are saying that is nothing but y is equal to a x power b. So this is another one. So these are all, if you observe that it is having two variables here x and y, and here also x and y, x and y, and in this one also x and y, and in this one also x and y. So each curve if you observe that we have two variables, and it is having a some relation between those variables by using the variables what we chosen. And fitting of that particular curves is nothing but finding the parameters. We are saying m and c, finding constants is nothing but fitting of this one. In the same way, a b c finding here, that is fitting of a second degree polynomial, or simply will say that parabola. In the same way, exponential curves. So these are the exponential curves we are saying a e power bx. It means finding a and b is a fitting of that exponential curve. In the same way, finding a b in this curve is also a fitting of that exponential curve. And another one is finding a b is a fitting of this power curve. So different names we are giving, and simply we call these all curves are nonlinear curves, and this is only the curve we called as a linear curve. And if we are perfect in linear curve, obviously we can get it these things easily. Why? Because we have to convert these non-linear curves into linear curve, and then we have to find the parameters what we require. Okay, so here it is ABC, and here also AB. Okay, in the same way AB here. So we'll calculate all those things for converting into linear curve, and then we'll calculate. Okay, so next, so we already said this all curves we are using the method of least squares. So which is the most systematic method to fit a unique curve through the given data points. It means that they give the data. So x values they will give and y values they will give, not x and y. That may be any variables, any two variables. So that data they will give. X values they will give as well as y values they will give. By using this data, we'll fit a unique curve. Only one curve will get. It means that suppose like we will get it as y is equal to 0.2 x plus 3. Okay, so like this, by taking this, finding this constant, we'll get only unique curve by using the given data x and y. Okay, so that is for that we use method of least squares. Okay, next one, fitting derived normal equations to fit a straight line. So very important essay question type. Derive normal equations to fit a straight line. In the same way, derive normal equations to fit a parabola. Derive normal equations to fit a exponential curve. So derive normal equations to fit a power curve. So all these things are very important. So that one we'll see here. So the proof of this one. Okay. Derive normal equations to fit a straight line. So first here it is, let y is equal to a plus bx be the straight line to be fitted to the given data. So first we are taking one straight line, y is equal a plus bx. Further we are taking assumption to be fitted to the given data. So by using the given data, one curve is fitting. That curve we are choosing as y is equal to a plus bx. And one more thing, don't by heart it. Here it is, y and x are not fixed, and a and b are also not fixed. Okay, so if you observe that in some of the cases like this, they give L is equal A naught T plus A1. So like this also they will mention. Here variables are nothing but L is variable and T is variable, and A naught and A1 are constant. These things we need to find. Okay, so don't by heart it, just we need to see the form. Okay, so here it is two variables and along with two constants. Okay, so this is the one by using based on that what they mentioned. Based on that we need to go through that. Okay, so here it is, first we chosen y is equal to a plus bx is a straight line to be fitted to the given data. Now we are taking the exact one. So here we are taking the assumption one, and we have already exact one. So let the straight line one passes through the given data points. Already we said the data passes through the points x1 y1 x2 y2 x3 y3 and so on xn yn. So we are writing as yi is equal to a plus bxi. So this is the exact one, and another one is what is passes through the data. So we have, so obviously some error will come. So some error will be there. So exact minus approximated one, right? So that only here we are writing the error between observed and expected value of y is equal to y. It means that actually some result. Suppose if you write the exam, after writing exam, you have some guessing. I guessing one, so I make it 90 marks. After getting the exam exact result, okay. So by taking that, obviously some comparisons or some ratio will be there, so some difference between that observed one as well as expected one. Okay, so that expected one and observed one is nothing but subtraction of those two will get in as error. right? So that only here we are saying that the error ei between the observed and expected value of yi is defined as EA is equal to YI minus A plus BXI whole square. Okay, so this is exact one, observed one, and this is expected one. So always we'll subtract from the exact. Okay, so exact value minus approximated value. And next, the sum of squares of these errors is given by. So it means that what we are doing, the sum of squares of these errors. This is only one EI. So for different values of I values here. So it means E1 is equal to what we'll get Y1 minus A plus B x1, and E2 is nothing but Y2 minus A plus Bx2, and E3 is nothing but Y3 minus A plus Bx3. So like that, right? So by adding all those things, it means that simply we have already what we have Y1 is equal, so Y1 is equal to A plus Bx1. Okay, so y1 is equal to a plus bx1, and next y2 is equal a plus bx2. So this is y2. So y2 is equal a plus bx2. Okay, and next y3 is equal a plus bx3, and so on. N is nothing but what we'll get yn is equal to a plus bxn. And now what we are doing, sum of squares of these errors we are saying. So it means that y1 square is nothing but a plus bx1 whole square, and next in the same way y2 square is nothing but a plus bx2 whole square, and y3 yn square is nothing but a plus bxn whole square general. What here it is what we are doing, errors sum. So sum of squares of these errors, it means that what we are writing, so yi minus this one is nothing but what we'll get e1 is equal, simply what we'll get e1 is equal to y1 minus of a plus bx1. Okay, this is error 1. So error 1 is a plus bx1, and next e2 is nothing but simply what we'll get y2 minus a plus bx2, right? This is error 2, a plus bx1 and a plus bx2. Okay, in the same way e3 is nothing but y3 minus a plus bx3. Squaring of this one is nothing but e1 square e2 square. Okay, it means this is whole square and this is also whole square. Okay, so squares of these errors, e1 square plus e2 square and so on. Okay, so plus and so on plus en square. So that is simply what we are writing in summation notation we are writing. So and we are giving name for that one as E. Okay, so that one we are giving as E. So E is equal to sum is nothing but summation. Okay, and squares is nothing but this one, and errors we are saying as En. Okay, so got it. Sum is nothing but summation, squaring, and next errors. Okay, so which is equal to what we'll getting. So ei square is nothing but this is a whole square. So whole square we are writing. Now we are expanding this one. So E is equal to, first it is substitute in place of I as 1, y1 minus of a plus bx1 whole square plus y2 minus a plus bx2 whole square plus and so on plus yn minus of a plus bxn whole square. Okay, next our intention is to minimize these errors. So minimizing these errors is nothing but, so already in intermediate or earlier classes we people did that one, finding maximum and minimum. Okay, so that is nothing but we need to apply partial derivatives with respect to the constants. It means simply what we have to do it, dou e by dou a is equal to 0 and dou e by dou b is equal to 0. So it means dou e by dou a is equal to 0. So it means we need to apply partial derivative e with respect to a and then equate it to 0. In the same way, next dou e by dou b is equal to 0. So e we need to apply partial derivative with respect to b is equal to 0. Okay, so these are the two things we need to do that, and then we'll get the two normal equations. Okay, so to minimize, so why we are using method of least squares means to minimize the errors. Okay, so that minimizing errors is nothing but we need to apply partial derivative with respect to a. Okay, so first we need to apply the derivative, right? So derivative is nothing but, first if we apply derivative for this one, simply what we'll get, first x power n is nothing but n into x power n minus 1. It means simply what we'll get 2 into y1 minus of a plus bx1. So 2 into y1 minus of a plus bx1 and whole power 2 minus 1. So that is nothing but simply what we are applying. So dou y dou a of this is simply we have x power n like, okay, or a power n. So this is we have. So here it is what we are applying, n into a power n minus 1 into dou by dou a of a. So this is the formula we apply general, right? So here also same thing, first we applied for 2 into y1 minus of a plus bx1 whole power 2 minus 1 into dou by dou a of this total derivative. So dou by dou a of, so what we have, y1 minus of a plus bx1. So y1 minus of a plus bx1, right? So this is the one. So in that, so 2 into this is as usual y1 minus of a plus bx1. So there is no change in that, y1 minus of a plus bx1 and a whole power 2 minus 1 is nothing but 1 and dou by dou a is nothing but here it is having, so y1 constant and with respect to a means, so y1 constant this is 0 and next with respect to a is nothing but what will get minus 1. Okay, so simply what we get minus 2 into a y1 minus of a plus bx1, so that one will get it here and next in the same way we'll get as usual. So as usual, we'll get it as same remaining one. So two, that's why here we wrote, if you observe this, what we got it minus 2 into y1 minus of a plus bx. In the same way, if you apply for second term also, we'll get it as minus 2 into y2 minus a plus bx2. In the same way and so on, last one also will get it as minus 2 into yn minus of a plus bx1. So if you observe this one, here it is having minus 2, here it is having minus 2 and here also minus 2. In the entire term we have minus 2 is the common one, so simply we can take that one as common and send that to right hand side. If it comes to this side, what will get 0 by minus 2, so 0 by anything is nothing but 0, right? So for that here whatever remaining, so y1 minus of a plus bx1 and y2 minus of a plus bx2 and yn minus a plus bx1. So that's why here we wrote like this. So what we did here, in the entire one minus 2 is the common one, we took that one common and sent to right hand side. Here it is multiplying, when it goes to right side it becomes division. So in 0 by anything is 0. So for that here we wrote 0. Now we need to simplify this one. So first we are writing all these things in one bracket, y1 plus y2 plus y3 plus and so on plus yn, and here it is having minus, so we have to take send this one into right hand side. Here it is having minus sign, when it goes to right hand side it becomes plus. So a plus bx1 plus a plus bx2 plus and so on plus a plus bxn. So if you observe, we didn't change anything in that. And next if you observe this one, a plus a plus a plus and so on plus a. So if you write like this, see that a plus a is nothing but what will get 2a, right? Next to a is nothing but 3a. Next to 4a, 5a. Like that, how many times here it is having? N times. So for that simply what we wrote here, na. And next in the remaining terms what we have, bx1, bx2, bx3 and so on bxn. In each and every term which one is the common one, b is the common one. Here b and here b and here also b. So after taking b as common one, whatever remaining, x1 plus x2 plus and so on plus xn. Simply we are writing that one in a summation notation. So summation yi is equal to na plus b into summation xi. So this is the first normal equation, we call that one. So simply we write summation y is equal na plus b summation x. So summation y is equal na plus b summation x. Okay, this is first normal equation. So next we need to apply the partial derivative with respect to b. Okay, same with respect to b means what we'll get again, see here. So same this one, with respect to b we need to apply. So as usual, first we need to write 2 into y1 minus of a plus bx1, right? So y1 minus of a plus bx1. So this is the one. And next into dou by dou b of, into dou by dou b of, so write on that one. So what will get, y1 minus of a plus bx1. So this is the one we are applying. So here it is, we are applying partial derivative with respect to what we are applying, only that one we apply derivative. Rest of the elements as constant and the derivative of constant is 0. So for that simply what we'll get, 2 into y1 minus of a plus bx1. This is as usual. Okay, so 2 into y1 minus of a plus bx1, and here what we'll get, this is a constant, derivative is 0, and a constant, this derivative is also 0. With respect to b we are applying, means what we'll get, dou by dou b of b is nothing but 1 into x1. It means simply what we'll get, x1, and already here it is having minus, so for that we'll get it as minus. It means what we'll get, minus 2x1 into this total one. Next second term, minus 2x3 into this total term. Next minus 2x3 into this total term. Like that it will get. So only the derivatives you need to know, that partial derivative. Okay, so that only here we wrote, see here. So first what we discussed, that one or not, minus 2x1 into y1 minus of a plus bx1 minus 2x into this one, and minus 2x into yn minus a plus bxn. Now we need to simplify this one. Same like as previous one, if you observe that minus 2 and minus 2 and minus 2. So this is the common one. So we need to take that one as common, and we have to send that one into right hand side. They here it is multiplying, when it comes to this side it become division, then what will get, 0 by anything is 0. Now we need to multiply x1 with this entire term and x2 with this one and xn with this one. If you multiply that, what we'll get, see here, x1 into y1 first term, next minus as it is x1 into a plus bx1, next x2 into y2, and minus into minus, next here it is what we'll get, x2 into a plus bx2. Okay, next one, and next xn yn, and next minus xn into a plus bxn. Now x1 y1, and here it is x2 y2 and so on xn yn. That one we wrote left side, and we are taking rest of all the terms into right hand side. So here it is x1 into a plus bx1 plus x2 into a plus bx2, and next xn into a plus bxn. Now you can see that you can multiply the terms, each and every term, x1 into a, that is nothing but ax1, and next x1 into x1 is nothing but x1 square, so for that b x1 square. Next x2 into a, that is nothing but ax2, and next b as it is, and x2 into x2 is nothing but x2 square, and next coming to this, a into xn is nothing but axn, and next xn into xn is nothing but xn square, so b as it is. So b as it is and xn square. Now if you observe again, here it is having ax1 and ax2 and so on axn. So in each and every term what we have, ax1 plus ax2 plus and so on plus axn. In the same way here it is bx1 square plus bx2 square plus bxn square. And now what we can take common in that, here it is a is the common one, right? We can take that one as common. Simply what we'll get, a into x1 square plus x2 square plus and so on plus xn square. So this is the one we'll get, right? So a into xn square. Next b into, so not a square terms now, a into x1 plus x2 plus and so on plus xn. And next coming to this term, what we'll get, b into, simply what we can take common, b is the common one in that, then what we'll get, x1 square plus x2 square plus and so on plus xn square. So this is the one. Okay, so a into this one and b into this one, so that one. And finally simply what we can write, that one, so summation xi yi, so where I is from where to where, 1 to n. So simply what we can write here, it is I is equal to 1 to n, xi yi is equal a into, so this is nothing but simply what we can write, summation xi where I is from 1 to n plus, in the same way b into summation I is equal to 1 to n xi square. Okay, so this is the another one. So this is second normal equation. So these are the two normal equations to fit a straight line. Okay, for the curve. So these are the two equations. You need to remember that whatever the equation they give, you need to write those normal equations. Let us see that how we wrote. So there we wrote y is equal a plus bx. This is the one we chosen. So simply you can remember that how we are writing that. First what we are doing, summation we are writing for variables. So summation we are writing for variables. Here variables are nothing but x and y. So for that, so this is summation, and for constant we are writing as n. Okay, next, here it is what we have, that one for each and every term we are multiplying with x. Summation xy is equal, and simply here also a summation x plus b summation x square. Why? Because x into x is nothing but x square. So these are the two normal equations to fit a straight line. Okay, so like this you can remember. So whatever they give in place of a and b, they give, or whatever they give, you can write in place of a and b those things what they give. And in place of x and y also same like as that. If they give L and T, you can write L and T. If they give another one, A naught A1 constants, A naught A1 will write. Okay, so this is the one you need to remember, that don't try to by heart it. Okay, try to understand how we are writing. So whatever the curve, first straight line they give, suppose linear curve or straight line they give, let me take it as one. Immediately you need to write two normal equations. In that normal equations, first you need to apply summation for the variables, and for constant you get n. N represent here number of values. Number of values they give in the given data. Next, you need to multiply x with each and every term. So here it is having x, and already here x into x is nothing but what will get x square and a summation x. Here n replace. Okay. So most of the people do the mistake writing normal equations only. Once if you write this one, easily you can get it. No doubt. Full out of full people will get that much of easy you can. So writing only normal equations important here. After that, completely based on calculation part. So it means we need to find all these things. So here it is, they give the values of x and y. What we have the variables we are saying, those values will get x and y. Okay, so these values will get. So by taking these values, we need to find summation x, and next we can find summation y, and next n representing number of values, and next here it is xy. So it means first what they give the values, we need to multiply those two values, x into y. So these two we need to multiply, and x square means we need to square the terms of x. And next we need to summation, in the sense what we get the values, we need to add all those values. After substituting those values in these normal equations, you people easily solve those two equations by calc, and then you get the values of constants a and b. And finally you need to substitute those values in y is equal some constants if people will get, those values you have to substitute here. That is the required curve of best fit. Okay, if you want you can check that one. So suppose like they gave the values x values and y values 0 1 2 3 like this they give. Okay, you can substitute x value here in place of this, and in y you make it approximated to this what they mentioned. Okay, so most of the problems same thing happens. Okay, this is the way you need to fit a straight line. Okay, so here derive normal equations to fit a straight line is also very important. Okay, next, so that only here we wrote solving the equations and g, and we get the required line of best fit. Okay, so let us see, very important, if you understand one problem then easily you can get it any problem. Okay, so see here first one, fit a straight line to the form y is equal to a plus bx for the following data. Here already they only mention the data. Okay, so they only mention the form. Okay, not data. Form also they only give y is equal to a plus bx. If they don't mention, you can choose the form y is equal to a plus bx or ax plus b, like that you can choose. If they mention, then you have to choose as it is. So here they clearly mentioned y is equal a plus bx. So x values they give and y values also they give. And here what we said, n represents number of values. Okay, so here it is. First you need to write these steps as it is. Okay, first one, the equation of this straight line is y is equal to a plus bx. So we didn't write any new thing here, just what they mentioned in the problem, given problem, that only we wrote here. So y is equal to a plus bx. Next, immediately for fitting a straight line, we require the normal equations. Those normal equations we wrote. So that only we wrote it now. Summation y. So first for variables we have to apply summation. So summation y and summation x. And now for constant we have to write n. Right? Next, we need to multiply for this one with x. That's why here it is c x, and x into x is nothing but x square, and next a summation x. Okay, now our intention is to find all these values by using the given data. Okay, this is the given data. By taking this given data, we need to calculate all these values. It means what are the values, what we require? X we require, y values we take, as well as what we require, x square we require. So x square, and next xy we require. So x1. So x already they give 0, 5 like this. And y also they give 12, 15, 17, 22. And x square is nothing but how we'll get 0 square is nothing but 0 and 5 square is nothing but 25. Like this you need to write. And next xy is nothing but what they give the values, we need to multiply these values 0 into 12 and next 5 into 15, 10 into 17, 15 into 22, 20 into 24 and 25 into 30. So after getting that, we need to add all those things. Then you get summation x, summation y, summation x square, and summation xy. Already summation x we calculated that one. And simply solving those equations by using calcs. Okay. So and finally we'll get the values of a and b. So this is the way you need to solve the problems on straight line. You can see that the values of x and y are. So x values and y values here we give. So x values, this is the given data they mentioned in the problem 0, 5, 10, 15, 20, 25, and y values they give. And x square means how we are getting squaring of these values. So that is nothing but simply what we did here 0 square. So 0 square is nothing but 0. Next here it is having next to x square is nothing but 5 square we did. And next what we have 10 square, so 100. And next one what we have 15 square, so 225. And next one what we have 20 square. Okay, so 20 square. And next one 25 square. Okay, so like this we got the values 625, 400, 225. And next what we calculate, these are the values of xy. So xy values is nothing but how we are getting by multiplying these values. 0 into 12 0, 5 into 15 75, and next 10 into 17 170, next 15 into 22 330, and next 20 into 24 480, and next 25 into 30 7. So this is, and now we need to calculate all these values. So summation x, summation y, summation x square, and summation xy. So those values we need to add. See, summation x is nothing but we need to add all these values. 5 plus 15, 20, 20, 20 plus 20, 40. Sorry, here it is 5 plus 10 15, 15 plus 15 30, 30 plus 20 50, 50 plus 25 75. Like this we need to add all these values. Okay, so like this we got the values here. So simply what we wrote the normal equations, so you need to take those normal equations. So what are the normal equations we wrote? Summation y is equal na plus b summation x. This is the first normal equation, and another normal equation is nothing but summation xy is equal a summation x plus b summation x square. So a summation x plus b summation x square. So these are the two normal equations. Now we need to substitute all those things. Here n represents number of values. How many values we have? 0 onwards they give 0, 1, this is 2, 3, 4, 5, 6. So n is equal to how much? 6. Now you can substitute all those values. Summation y, how much we got it? 430. So 430 is equal to n is nothing but 6. And a we don't know that, we need to calculate. And next b summation x. Summation x is nothing but how much? 75. So 75b. And next one, summation xy. So summation xy is nothing but this is the value 1805. So this is summation xy. And next, summation a into summation x. Summation x, how much we got it? 75a plus b summation x square. So b summation x square. Summation x square is how much we got it? 1375. So 1375b. That's it. Now, by taking calc, you have to substitute the values. Please take care of that when you are solving in calc. Okay. Why? Because you people have to start from equation this onwards. First, you need to start for 6, 75, and then 430. Your calc equation is looking like that. So ax plus by is equal to c. Okay. So next 75, 1375, next 1805. and then press equal to, you'll get the values. There it is in your calcium, you get it as x and y, but here it is we are representing a and b. So first value you can choose as a and second value you can choose as b. And don't forget it, after getting these values we need to substitute finally in the given one. So what we chosen, y is equal to a plus bx, right? So y is equal to a plus bx we chosen, and simply we can substitute those values. So what we got it, a value as well as plus b and into x. This is the required straight line of best fit. That one will say that. This is the pattern need to follow for fitting a straight line. Okay, so no doubt at all. So simply this is the way you need to apply. Only the important thing is writing the normal equations one thing, and calculations. If you miss one value also, you will get surely wrong. Okay, so you people think that very easy. So that much of difficulty also. Why? Because with careless, simply we know very easy we can do it calculations. Simply if miss 1 0, obviously what will get? It will go wrong. Obviously substituting wrong, and final result also wrong. Everything wrong. So that's why you should take care of that when you are applying calci. And first writing the important one is normal equations. Okay, I am saying surely you people easily can solve the problems in first part. Anyone. Why? Because completely based on calculations. Only you need to remember these two. Okay, so this is the one, and we need to substitute. So this is a procedure for fitting a straight line, or in another words we can say that linear curve. So that only we substituted and we solved those values and we got it these values. So this is the process we need to apply. Okay, so same in the same with the temperature T and length L in mm of a heated rod given below, and relation also they give. So it means in place of generally what they give. So generally what we said here it is y is equal to a plus bx. In first column they give, right? A plus bx they give, right? But here it is what they give. In place of y they give L, and in place of x they give T, and in place of a as a naught, and in place of b as a1. So if you see that there it is having, they change the values also. So directly don't think as this is x and this is y. Okay, see clearly here it is. Okay, so this is also important. So here it is, whatever t is nothing but x values, and this is y values. Sometimes they may change that one. Okay, so it means simply what we have to write in summation. So generally what we are writing normal equations means summation y is equal na plus b summation x. So this is the first normal equation we are writing, right? And next we are writing another normal equation is summation xy is equal a summation x plus b summation x square. So this is the another normal equation we are writing, right? Summation x square. And now if you compare this one, in place of y what we have L. So further simply what we have, right? Summation L is equal to n into, in place of a what we have a naught, and in place of b as a1, and summation x is nothing but what we have t, summation t. And next summation lt in y, because in place of x as here t, and in place of y as here. And next a in place of a as a naught, and summation x is nothing but t, and b is nothing but a1, and next summation x square is nothing but t square. See, just you can write in rough like this, and then you can substitute whatever the problem. Don't get fear by seeing the length of the problem. They may mention anything, we require the form, and immediately we need to substitute the values. So now we need to find L, already t they give, and next L, and next we need to do t square, and next we need to calculate TL, and next we need to find summation t, summation L, summation t square, summation TL. By substituting all these values in that, we'll get, and solving will get as a naught and a. Okay, so this is the process we'll apply for straight line. So whatever the problems we have, we'll apply all these problems by same like this. Okay,